Hi everyone, here is our activity about adding resistances and the impact that different configurations of resistances have on the overall current in our circuit. I have here what's called it's actually called a multimeter. I've set it up to be what's called an ammeter to measure the amps, the current in the circuit through this light bulb. So I've connected everything such that it'll measure the current from a 2-battery circuit through either one light bulb or 2 light bulbs that we'll get to in just a second. This number here is in amps and it's the current in the circuit. So the first thing I have is I want you to make note in this activity the current when I connect one light bulb to 2 batteries. So this is a single light bulb circuit. We see the light bulb is on like it was before, and now we know that that current is 0.25 amps. 0.25 amps for one light bulb. The next thing we're going to measure is 2 light bulbs in 2 different kinds of circuits. So the first circuit I'm going to make is when I had the 2 light bulbs one right after the other, just like our simple circuits activity. This is called a series circuit. So I'm going to open up my circuit and break it. You'll see that the current drops to 0. The light bulb's not on. And I'm going to insert in a straight line another light bulb. So I have one wire. All it does is connect one light bulb back to the other light bulb. And then this needs to be connected back to our batteries. We expect that these 2 light bulbs are both going to light up dimly. And they do. And we see a smaller current. So now our current is 0.19 amps for a series circuit. In series, our current has dropped to 0.19 amps. Now we are going to connect the bulbs, a third way with what's called a parallel connection. So I'm going to now, let's see, the easiest way to do this is to jump off here, and I do need another wire or 2. Good. Just a moment while I connect everything together. There. Now we see that I've got a place for my current to split. The current comes in on this black wire here, and it can go through this light bulb, or it can go along this wire to this light bulb. And then it's a little bit hard to get everything on camera, but the wires come back together to join back to the battery. And when I do that, just like in the activity, let me get a good connection there. And good. I've got 2 bright light bulbs. They're glowing brightly, and we see our current has gone up to 0.44 amps. So that would be the current for our parallel connection of light bulbs. So the activity is pretty short. I want you to use those currents and use Ohm's law to determine what must be happening to the resistances of a series or a parallel connection. Excellent work.